So continuing on with the fill-in-the-blank section of the test, on number 21 here we're asked to write the correct configurations for chlorine. So if you look at the periodic table for chlorine, it'll say 17, and it'll have, it'll say 35.5, I think it's 35.453, but we'll just say it's 35. So that tells you that it's got 17 electrons. So of those 17 electrons, 2 of them go into 1s, the next 2 go into 2s, and after the 2s comes the 2p. After the 2p comes the 3s, and after the 3s comes the 3p. Now if you take time to count, you got 2, 4, 10. That's supposed to be a 2. I don't want to do that right now. That's supposed to be a 2. Then over here would be a 5. So let me try that again. I don't really know how to get rid of that. There we go. That's how I get rid of it. So I'll come over here real quick. Put on my eraser. Get rid of that. I'm going to rewrite that for you. All right, let's try this again. Try not to hit any funky buttons on my pen. All right, so we have a 1s2, 2s2, 2p6, 3s2, and then 3p5. That makes 17. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. Another way to do that is to follow through the periodic table, like this. So here's chlorine right over here. So you go 1s2, 2s2, 2p6, 3s2, come across to 3p, and it's 1, 2, 3, 4, 5. So there's chlorine, 3p5. The electron's in the outer shell. Well, if you look at the outer shell, it's right here. You got the 3s and the 3p in the outer shell. So that means there'd be how many in the outer shell? Kind of looks like 5 plus 2 is 7. Okay, now the orbital diagram for bromine. I'll go ahead and draw the boxes. So you have a box here, a box there, that's 2s, 2p. Whoops, that wasn't a very good box. There's 2p. 3s, so that's 1s, 2s, 2p, 3s, 3p will be next, 4s, 3d, and then 4p. Alright, so putting the boxes in 1, 2, 3. A circle, a D would have 5 boxes. And then the P will have 3 boxes. Okay, these are all the orbitals. So put the electrons in. Uh-oh. I don't really want to take that out, so but I'm going to have to. Oh wait, maybe I could do this. There we go. Look at that. I'm getting smarter. Alright, so but now I'm getting not so smart. All right, there you go. 1, 2, 3, 4. Up, 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 down, 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 up, down, up, 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 down, down, down. Forgot to tell you that if you look at the periodic table, you'll find bromine is 35 and 80. So 35 electrons. So we got 2, 4, 10, 12, 18. $19, $20, $21, $22, $23, $24, $25, $26, $27, $28, $29, $30. Still got to go to 35. Okay, so here we go. 30. What did I say I was at right here? That was 30. Oh, I know. So I've got to put this guy in over here. Okay, there's 30. There we go, finally. There's 31, 32, 33, 34, 35. So that's your orbital notation. Only includes the electrons. Remember, there were 80 protons. Another way to do it would be 1s, circle, 2s, circle, 2p, 3 circles, and so on. I like the circles better, but I'm not going to redraw them all. Then how many electrons in the outer shell of bromine would be 7. And you see the 7 because they are right here. 1, or that's 2, 4, 5, plus these 2 down here in the 4s. That's where the 6 and 7 come from. All right, now which electron configuration is shown below? Krypton's got 36 electrons, plus 2 for the 5s, plus 10, plus 3, that equals 51. And 51 is the number of electrons that are in antimony. So the answer to that was SB. Okay, now dot diagrams, that is a valence shell only for the following atoms. So if you look at nitrogen on the periodic table, it says nitrogen 7, 14. So 1s2, 2s2, 2p3. We want the dot diagram which shows only the outer shell electrons, so that's 5 of those. So you put in here, the 2 electrons that are in the 2s would go right here, and the 3 electrons in the 2p would go here, and here, and here. They'd go by themselves. It's kind of like if you said nitrogen has the s orbital box right there, that's the s, and then the p orbital box here, and the second p orbital box there, and the third p orbital box there. Okay, now aluminum, if you look at aluminum, remember the easy way to do this was to count the columns. So looking at nitrogen, first column, second column, third column, fourth column, fifth column. So if you look at aluminum, where's it? Third column, 3 valence electrons. Not 5, but 3. So come over here, and we write down aluminum symbol Al. We'd have a pair of electrons there, and then the 1 electron by himself. Because aluminum will end in 3s2, then 3p1. So the 2 electrons here are those, and this 1 electron here is that one. All right, and then germanium, if you look at it on the periodic table, has 34 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, you look at the number of electrons in the 2p, there'd be 6. Number of electrons in the 3p, there'd be 6. Number of electrons in the 4p, there's 2. So 6 plus 2 equals 14. And that is the number of electrons in all of the p sublevels of germanium. I was going to draw an arrow. There we go. 14. All right, that's the end of that section of the test. So now I have I've covered all the electron configuration stuff. Now I'll move on to the fill in the blank page a little later on.